Hello and welcome to question 4 here in our Tricky A-Level Maths exam question series. Now for today's question then, as you hopefully recognize here, we have a question on integration. If you don't recognize this as integration, you're probably on the wrong video. So definitely don't continue if you don't recognize this as an integral. Now for this question here, as we can see, it just says show that. You're then given this integral here from 0 to 2, integrating with respect to x, and we want to show this here. And as we can see then, 7 marks for this question. Now what you might recognize here is there is no specified method for the integration, right? Normally, you'll be given an integral and it'll say use integration by parts or use integration by substitution, something like that. However, for this question here, it doesn't specify a method, so it's completely up to you which method you choose here. Now, I am a firm hater of integration by parts. I'm not going to be doing integration by parts, but I will do integration by substitution. But if you do prefer integration by parts here, that's absolutely fine. Just make sure then you do get the correct answer, right? If you don't get this, something's gone wrong, clearly. But yeah, let's begin then with this question. So like I said then, I'm going to use integration by substitution here. So clearly I need to start by choosing an appropriate substitution. So to begin with here, I'm going to let then u be equal to this here, x plus 2, okay? So let u be equal to x plus 2. Now, I look at the integrand here, so that's the thing that we want to integrate, and I recognize that we've got 3 parts. We've got 2x, the square root of x plus 2, and dx. So I need an appropriate substitution for each one of these things, right? So for the square root of x plus 2, that's straightforward. That's just simply root u, right? Nice and easy. Now for the 2x then, how do we do that, or how do we deal with that? Well, if u is equal to x plus 2, then in that case here, just rearranging and making x a subject. So in that case then, x here is simply u minus 2. And clearly then 2x is just 2 lots of this, right? Again, nice and easy. And what about dx then? Well, all I'm going to do here is just differentiate u with respect to x. We get du by dx then. So du by dx here is just simply 1, right? And in that case then, dx here is equal to du. Perfect. And don't forget as well, when you're integrating by substitution here, we do also need to replace the limits, right? So the original limits here from 0 to 2 will not apply once we rewrite the integrand, okay? So I'll just do this underneath here as well. So for the new limits then, what do we get here? So to obtain the new limits here, I can't speak. So to obtain the new limits here, we just use this substitution, right? U is equal to x plus 2, where x is 0 and x is 2. So when x is 0, u in that case then is 0 plus 2. We just get 2, right? So when x is 0, u is 2. And when x is 2, that being the original upper limit here, then u is simply 2 plus 2, which is 4, right? Perfect. So we've now got everything that we need here to rewrite this integral, okay? So let me just start by, not rewriting, but writing down this integral here. So we go from 0 to 2 then, of 2x times the square root of x plus 2. So x plus 2, and we're integrating here then with respect to x, okay? So let's just rewrite then the integrand here using all of our substitutions and our new limits then. So we're integrating here from 2 to 4. So we integrate from 2 to 4. So 2 to 4. 2x then is 2 lots of this here. So 2 lots of u minus 2. So 2 lots of u minus 2. I then got the square root of x plus 2, so as we mentioned at the beginning then, let's just simply root u, or u to the power of a half, whichever you prefer here. So root u. And then we've got, so what do we have here? Dx, right, which is simply du. Perfect. Okay. So let's just simplify the integrand here, because trying to integrate this in its current form is not particularly nice. So expand this bracket here, so I get 2u minus 4, then times it by u to the power of a half, right? So if I do that down here, again, the limits won't change. So we're going from 2 to 4. From 2 to 4 then, As I just said, I get 2u minus 4 times that by u to the power of a half. So I put the u to the power of a half at the front. I've then got 2u minus 4. Okay, I'm integrating here then with respect to u. Perfect. Okay, so just multiply through here. So u to the power of a half times 2u. So what we get here then, don't forget the integral symbol, of course. So from 2 to 4. So that's 2u to the power of 1 times u to the power of half. I get 2u to the 3 over 2. So 2u to the 3 over 2. And then minus 4 times u to the half. I get minus 4u to the half, right? This should hopefully be nice and straightforward. So 4u to the power of a half. And again, we're just integrating here with respect to u. So du there. Okay, I'll put brackets around this here just to indicate that we're integrating the full expression. So this integral here then should hopefully be nice and straightforward. This is just basic year 1 A-level maths integration, right? Just add 1 to the power, divide by the new power. So what do we get here then? And this will now go inside the square brackets here because we're now actually evaluating the integral then. So I get 2u, add 1 to the power, so 3 over 2 plus 2 over 2, I get 5 over 2, and then divide by 5 over 2, right? So I get 2u to the 5 over 2, and that's all over 5 over 2. Now, if you do prefer to kind of simplify this all in one step, that's absolutely fine. I'm just trying to show all individual steps here as I go, so hopefully I don't cause any confusion. And then for this term here, again, just add 1 to the power, divide by the new power. So what I get here then is minus 4u to the 3 over 2, so 1 over 2 plus 1 is 1 over 2 plus 2 over 2. We get a power of 3 over 2. So 3 over 2 like that. And again, we just divide by the new power, right? So I'm dividing here by 3 over 2. Perfect. Close the brackets here. And don't forget our limits of integration from 2 to 4. Perfect. So at this point here, what we now need to do then is just simply substitute in the limits, right? Start with the upper limit, subtract the lower limit. So what would I get here then? So we start with the upper limit then of 4. So basically you just replace u with 4, right? So I've got 4 to the 5 over 2. So that's the square root of 4, which is 2. Raise that to the power of 5. So I get 2 to the 5, which is 32. Times that by 2, so I get 64. And that's all over 5 over 2. Now, to make my life easier here, what I will do then is just simplify this here. It just makes my life a lot easier, basically. So dividing by 5 over 2 is the same as timesing by 2 over 5, right? So what I get here then is, I get 2 times 2, which is 4. So, sorry, let me just get rid of that, just so I don't cause any confusion. So I get 4u. So 4u to the 5 over 2, all over 5. Clearly, by the way, you could just do this on a calculator. I'm just doing it kind of by hand here rather than using a calculator, but if you want to play it safe in an exam, just use a calculator, right? You don't get any extra points or any extra marks, right, for doing this by hand. So I get 4u to the 5 over 2 all over 5, minus them. So what I do here is I do 4 times 2, which is 8. We get 8u to the 3 over 2 all over 3. So 8u to the 3 over 2 all over 3. Okay. And again, the limits here don't change. So from 2 to 4. So as I mentioned before then, we replace u here with 4. So I get 4 to 5 over 2. So that's the square root of 4, which is 2. Raise that to the power of 5, which is 32. Times that by 4. And that's all over 5. So I'll do this underneath here because I'm probably going to run out of room. So 4 lots then of, so 4 lots here of 32 all over 5. Subtract this then with this here. So minus 8u to 3 over 2 all over 3. So again, take the square root of 4 here. So that's 2. Raise that to the power of 3, which is 8. So 8 times 8, which is 64. So I get minus 64 over 3. So that's my upper limit here. We now subtract the lower limit then. So minus here. So now replace u with 2 here. So I've got the square root of 2, raise that to the power of 5. So that's root 2 times root 2 times root 2 times root 2 times root 2. So root 2 times root 2 is 2. We do that again. So 2 times 2 is 4. So what I get here is 4 root 2. So I've got 4 lots of 4 root 2. And that's all over 5, like so. I then subtract here, this here, right? So 8u to the 3 over 2 all over 3. Again, just replace u with 2. So what I've got here then is the square root of 2, then raise that to the power of 3. So root 2 times root 2 times root 2. So root 2 times root 2 is 2. And by root 2, I get 2 root 2. So I've got 8 lots of 2 root 2, right? So 2 root 2. And that is all over 3. Okay, perfect. Now, clearly at this point here, we are a little bit off what we actually want. So it's just a matter of simplifying, and hopefully we should be able to work towards this desired result. Okay. So 4 times 32 over 5 minus 64 over 3. Let's just do this over to the right here. So 4 times 32, so I get 120. And then 4 times 2 is 8. So 128 over 5. 128 over 5. I am doing this without a calculator, so I'm probably going to make a mistake, but we'll see how far we get. So 128 over 5 minus 64 over 3. So minus 64 over 3. This here then, if I just simplify that as well. So minus here, and that's 16 root 2 over 5. So 16 root 2 all over 5. Minus then, so I get 16 root 2 over 3. So minus 16 root 2. 16 root 2 over 3. Okay. Now, at this point here, I'm going to have to use a calculator or just check my notes, right, just to make sure that once I start doing the simplifications here, I do actually get this correct, because I cannot do mental maths for my life. So basically, at this point here, we just need to get these over a common denominator, right? So I'd have to times this fraction by 3, times this fraction by 5. And you do the same here with this fraction. You times that one by 3. And you times this one by 5, right? So what I'll do here is I'll do this underneath then. So 128 times by 3. I'm going to use a calculator because I would definitely make a mistake. So 128 times by 3. That's 384. 384 over 15. And then times 64 by 5. So that gives me 320. So minus 320 over 15. Then a bracket as well. Minus then this here. So minus then 16 root 2 over 5. Again, I'm just going to times this by 3. So it's going to be 48 root 2, right? I can do that without a calculator. I'm not too bad. So 48 root 2 over 15 minus them. So what I'm going to do here is times this by 5, right? So that's going to be 80. So minus 80 root 2 over 15. So 384 minus 320, that's going to be 64, right? I get 64 over 15 minus them. So 48 root 2 minus 80 root 2, that gives me minus 32 root 2 over 15. So this bit here is negative, but because we're subtracting that, it's just the same as adding it, right? So what I get here is plus 32 root 2 all over 15. Perfect. And at this point here, hopefully you can now see what we need to do then. Clearly what I need to do here is pull out a factor of 32 over 15. So I pull out a factor of 32 over 15. I get 32 over 15 bracket. So what do I times 32 over 15 by to get 64 over 15? Well, that's just clearly 2, right? So I get 2 there. And what do I times 32 over 15 by to get 32 root 2 over 15? Well, clearly that's just root 2, right? So I get 2 plus root 2. And just notice here then, that is exactly what we want here. So as required then. So as required. And there we have it. Question complete. Okay. Now I can see here that this question is nearly at 15 minutes. Clearly it's probably not going to take 15 minutes in your exam because I am kind of narrating each and every step here, which you shouldn't be doing in an exam. You'll get caught for cheating or they'll wonder what you're doing if you start reading out in your exam. So don't do that. Definitely not an exam tip. But, you know, it shouldn't take you quite as much time as it's took me here in your exam. But hopefully this explanation, this demonstration here has helped. So 32 over 15 times by 2 plus root 2. Perfect. It's beautiful, right? So there we have it then. So hopefully that has helped. And that gives us the solution here to day 4 in our trick here A-Level Maths exam question series. As always, thank you for watching.